Hi, welcome to Sunil Maths tutorial, Fourier series, class number 2. Let us see one problem. Find the Fourier series to represent f of x is equals to x square in the interval 0 to 2 pi. So they given that f of x is equals to x square and the interval is from 0 to 2 pi. So Fourier series entirely depends upon integration. So to understand and to solve the problems in Fourier series, it is necessary to understand the integration formulas and how to work with Bernoulli's principle. It is very simple and easy. Let us see Bernoulli's principle or Bernoulli's rule of integration. Bernoulli's rule of integration. Integral uv dx is equals to uv1 minus u dash v2 plus u double dash v3 and so on. Everybody knows that u dash means derivative of u dash means derivative of u double dash means second derivative of u and so on. V1 means integral v, v2 means integral v1, v3 means integral v2 and so on. To understand this principle, let us work out with an example. Integral x square cos 3x dx. It is in the form of integral uv dx. It is in the form of integral uv dx, where u is equals to x square, v is equals to cos 3x. Now u dash, the derivative of x square, 2x, u double dash, the derivative of 2x, 2, u triple dash, the derivative of double dash, 0, v1 integral v dx, integral v dx. Now see, v1 integral v dx means integral cos 3x dx. It is nothing but 1 by 3. It is nothing but 1 by 3 sine 3x. Now v2 integral v1 dx. It is equals to integral 1 by 3 sine 3x dx. Integral sign minus 1 by 9 cos 3x. Everybody knows integral cos ax dx is equals to 1 by a sine ax. Integral sine ax dx is equals to minus 1 by a cos ax. Remember the formulas. Now we go for v3. v3 is equals to integral v2 dx. It is equals to integral minus 1 by 9 cos 3x dx. So it is very simple, minus 1 by 27 sine 3x. Now by applying the Bernoulli's principle, you see integral x square cos 3x dx is equals to integral uv dx, which is equals to u v1 minus u dash v2 plus u double dash v3 minus and so on. Now see, what is u? X square. What is u? X square. What is u? X square. What is v1? 1 by 3 sine 3x minus u dash 2x. What is v2? Minus 1 by 9 cos 3x. u double dash. In the formula we have plus 2. v3 minus 1 by 27 sine 3x. After simplifying this, you get simply x square by 3 sine 3x minus into minus plus 2x by 9 cos 3x minus 2 by 27 sine 3x. This is the working principle or how the Bernoulli's principle works. So learn this integration, then Fourier series is very simple and easy. So now we go for our problem. Here it is given that f of x is equals to x square and interval is 0 to 2 pi. Now we go through with the Fourier series. The Fourier series expansion is given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity an cos nx plus summation n is equals to 1 to infinity bn sin nx. This is the Fourier series expansion. Here a naught is equals to the formula for a naught is equals to 1 by pi integral 0 to 2 pi f of x dx. Because the interval is from 0 to 2 pi, so we use the limits integral 1 by pi 0 to 2 pi f of x dx. So this is nothing but 1 by pi integral 0 to 2 pi x square dx. X square dx. So x square means integral x square means x cube 1 by pi x cube by 3 integral 0 to 2 pi. No need to substitute the lower limit, you substitute the upper limit. 1 by pi or 1 by 3 pi 2 pi whole cube. This is the upper limit. So 2 cube 8 divided by 3, 1 pi get cancelled. So 8 pi square by 3. 8 pi square by 3 or 8 by 3 pi square. So therefore we conclude that a naught is equals to 8 by 3 pi square. This is the first term. Excuse me. Now we go for second term. an is equals to, the formula for an is equals to 1 by pi integral 0 to 2 pi f of x cos nx dx. F of x cos nx dx. So obviously this is 1 by pi. We use the Bernoulli's principle. Integral 0 to 2 pi f of x means x square cos nx dx. In the previous example, here we solve with 3x, but we have here nx. That is the only difference. So we go through with it. 1 by pi, 1 by pi, 1 by pi, x square, x square, x square, integral cos nx sin nx by n minus of minus plus 2x, because integral sin x we get minus, integral sin x we get minus cos x. So cos nx divided by n square minus 2 minus 2. Here also you see that you get minus 2 here also, because of we are integrating cos 3 times. So minus 2 sin nx divided by n cube, and the limits are given by 0 to 2 pi. For your understanding, I repeat the integration. You please observe that integral cos nx dx is equals to sin nx by n. If you integrate one more time this minus cos nx by n square. If you integrate one more time this, you get minus sin nx by n cube, and so on and so on. So by using this calculation, here we get x square sin nx by n plus 2x cos nx by n square minus 2 sin nx by n cube. Whenever you substitute the lower limit, here you observe that the lower limit is 0. The lower limit is 0. If you substitute the lower limit x square, in place of x square, the term 0, here it is 0, sin 0, 0. So completely the lower term becomes 0. The lower limit gives 0. Now only you have to substitute upper limit. So let us go for it. 1 by pi x square means 2 pi whole square sin n 2 pi by n plus 2 into 2 pi cos 2n pi by n square minus 2 sin 2n pi divided by n cube. And remember the basic fact, sin 2n pi is equals to 0 for all n belongs to capital N. Sin 2n pi is equals to 0 for all n belongs to capital N. So this condition implies as this term, first term is 0, the last term is also 0, and the only term is third term. Now we go for it, which is equals to 1 by 5, not third term, I mean second term. 2 into 2 pi, here 2 into 2 pi, 4 pi, cos 2n pi, you remember that. Cos 2n pi is equals to 1. Cos 2n pi is equals to 1 for all integers. For all integers n belongs to z. By applying this one, you get 4 pi into 1 divided by n square. Now the pi get cancelled. You simply get 4 by n square. 4 by n square. Therefore, we get an is equals to 4 by n square. An is equals to 4 by n square. Now we are going to calculate bn. Bn is equals to 1 by pi integral 0 to 2 pi f of x sin nx dx, which is equals to 1 by pi integral 0 to 2 pi f of x means x square sin nx dx. Again, this is in the form of Bernoulli's principle. Integral 0 to 2 pi uv dx. So apply the Bernoulli's principle here. So we get 1 by pi into derivative of x square 2x. First, remember that x square integral sin nx minus cos nx by n minus of minus plus 2x sin nx by n square minus 2 into integral cos nx. You simply get minus cos nx plus 2 sin nx. Again you are integrating, you get cos nx divided by n cube limits from 0 to 2 pi. So now we go for it. Let us simplify. Whenever you again observe that if you substitute the lower limit 0, so this term is 0, this term is 0. In the whenever you substitute the lower limit, you get only this term. This is not equivalent to 0, you get only answer for this term. So go for, whenever you substitute upper limit here, sin 2n pi, that is also equivalent to 0. The second term is completely becomes 0 because of for lower limit as well as for upper limit. So now we go for upper limit. 1 by pi, x square means minus already there, 2 pi whole square cos 2n pi divided by n. The second term completely 0. Even the lower limit for the first term is also 0 for the lower limit. First term is also 0 for the lower limit whenever you substitute x equal to 0. So now the last term for upper limit minus 2 cos 2n pi divided by n cube. And for 0 upper limit minus lower limit, and for 0 minus 2 cos 0 degrees by n cube. This term is from upper limit minus lower limit. So now simplify again the next step, which is equals to 1 by pi minus 4 pi square. This cos 2n pi gives us 1. Cos 2n pi is equals to 1. 4 pi square by n minus 4 pi square by n minus, here also this cos 2n pi is 1, minus 2 by n cube. Here cos 0 degrees is 1, minus into minus plus 2 by n cube. Now you observe that plus 2 by n cube and minus 2 by n cube you get cancelled, and you simply get 1 by pi minus 4 pi square by n. So 1 pi get cancelled, you simply get minus 4 pi by n. This is nothing but Bn is equals to minus 4 pi by n. Bn is equals to minus 4 pi by n. So now we have all the three values, that a naught, I think a naught is equals to 8 by 3 pi square and an is equals to 4 by n square. Using all these values, using a naught, an, bn in Fourier series expansion, f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity an cos nx plus summation n is equals to 1 to infinity bn sin nx. What is f of x? X square a naught by 2. A naught by 2 means 4 by 3 pi square plus summation n is equals to 1 to infinity an 4 by n square cos nx plus summation n is equals to 1 to infinity bn minus 4 pi by n sin nx. This is the required, this is the required Fourier series, for the function f of x, is equals to x square. So right, that's it. In the next video we learn some more problems in the same method. So in this you can practice one more problem. Find Fourier series expansion for the function f of x is equals to x, in the interval 0 less than or equals to x less than or equals to 2 pi. So this is homework for you. You do work by using the previous same method. Find the Fourier series for the function f of x is equals to x in the interval 0 to 2 pi. Wish you all the best. Keep learning.